Hey guys, welcome back to Helper Function. In this video we will discuss how to search in a rotated sorted array. So suppose an array sorted in ascending order is rotated at some pivot unknown to you beforehand. Now you are given with the target and you need to find whether this array contains the target or not. If found in the array, return its index, otherwise return -1. Also, it is given that there are no duplicates in the array. Let's suppose we have this array sorted in increasing order. Now in the upper array, they are rotated by 1 unit to its right. Thus all the elements are shifted one step right, while the last element have come to index 0. And in the second figure, the array is rotated 3 units to its right. Thus 1, 2 appears at last and 3, 4, 5 at the beginning. And now our task is to search our target in one of these rotated sorted arrays. So let's see how we will solve this. Now the brute force approach to solve this problem is running a loop and finding the target by comparing with every element. But this will not work in an interview because we have more optimal approaches. If we look at the array, if the array is rotated, it will have two sorted parts. Here 4 to 7 is one sorted part and 0 to 2 is another. So being at any index, we will definitely have one sorted part either on left or to the right. Now if the array is already sorted, we will have the sorted parts on both the sides. Let's understand by this example. Now we are at 7 and we can see that 4 to 7 is sorted, that is the left part is sorted, while 7 to 2 is not sorted. Now we are at 6 and again 4 to 6, that is the left part is sorted while 6 to 2 is not sorted. And now we are at 0, we see that 4 to 0 is not sorted, but this time 0 to 2, that is the right part, is sorted. So how to check which part is sorted? Simple, we just need to compare that element with the first or the last element of the array. We'll be comparing with the last element. So if my present array element is lesser than the last element, this means that this portion is sorted, that is the right portion is sorted. Otherwise, the left portion is sorted. So as 0 is lesser than 2, which means that 0 to 2 is sorted. And now here, as 7 is not lesser than 2, which means that the left part is sorted, that is 4 to 7. Now as we know that which part is sorted, we can use this sorted part to search our target. If our target lies in that sorted range, then we will move to that sorted part, otherwise we will move to the other part. Thus we will be using binary search to solve this problem. We have two pointers left and right and mid is the middle element. Anytime the array of mid is equals to target, we will return mid. Now in third line, if array of mid is lesser than array of right, which means that the right part is sorted. So we enter this if condition, and now if my target lies in this range, that is between array of mid to array of right, we will move to the right, otherwise we will move to the left. Similarly, if right part is not sorted, we will enter this else condition where the left part will be sorted. And now if my target lies in this sorted range, that is from array of left to array of mid, we will move to the left, otherwise we will move right. Now we will keep on doing this until our left is lesser than equals to right. So let's understand with this example. So left is initially at 0, right is the last element and mid is the middle element. So we compare a of mid to a of right, and as 7 is not lesser than 2, we will move to the else part, which means that my left part is sorted. Now we will check if the target lies in this range or not. And as 0 is not in range 4 to 7, we will move to the right. That is, my left pointer will now come to mid plus 1. Now again we compare a of mid to a of right, and this time 1 is lesser than 2, which means that the right part is sorted. But as 0 is not between 1 and 2, we will move to the left part. That is, my right will point to mid minus 1. And now as a of mid is equals to target, we will return mid. Now let's look at the code. We are initially given with a vector A and a target value. N is the size of the vector. Left is initially at 0 and right is initially at n minus 1. Now this while loop will work till left is lesser than equals to right. Here we get the index of the middle element, and if a of mid is equals to target, we will return mid. Otherwise, we will check that if a of mid is lesser than a of right, which means that the right part is sorted. So if we enter this loop, now we will check that if my target lies in this range or not. I mean, if the target is greater than a of mid and it is lesser than a of right. If it is true, then we will move right, which means that left will now point to mid plus 1. Otherwise, we will move left, which means that right will point to mid minus 1. Otherwise, we will move to this else portion, which means that the left part is sorted. So we will again check if the target lies in this range or not. That is, if my target is greater than a of left and if it is lesser than a of mid. Then we will move left, which means that my right will be mid minus 1. Otherwise, we will move to the right, which means that left will be mid plus 1. Now if this while loops terminate and we have not found our answer, so we will return minus 1, which means that this element is not present in the array. So let's try with the example where the target element is not present in the array. So initially I compare a of mid with a of right, and as 7 is not lesser than 2, we will move to the else part, and as 3 lies between 4 and 7, we will move to the left, which means that right will be now at mid minus 1. Now here 5 is lesser than 6, which means that right part is sorted. But as 3 does not lies between 5 and 6, we will again move to the left, which means that right will be at mid minus 1. Now here left and right are both at same position. So as array of mid is not lesser than array of right, so we will move to the else part, and because 3 does not lies between the range 4 to 4, we will move right, which means that left will be pointing to mid plus 1. Now this time left will be greater than right and my while loop will terminate. Thus we return minus 1 as our answer. As we are using binary search, the time complexity to solve this problem is big O of log n. And because we are using no extra space, the space complexity is constant, that is order of 1. So this was all about the problem. I put the problem link in the description so you can go and solve it. Also, if you have any doubt or suggestion, please write in the comment. Thank you for watching. Do like, share and subscribe to the channel for more such videos.